ions of transition metals and their charges. So, if you remember, I told you guys that we talked about groups 1 and 2, and then groups 3 through 8. So the first 2 on the left side of the periodic table, and then the last 6 on the right. Right? And I said in between there's the transition metals, and we would deal with them separately because the transition metals have funny rules. Right? Groups 1 and 2, and then 3A through 8A, they're all simple. It's pretty much the group number, tells you what the charge is. It's not the big group number, for some it is. But for the transition metals, it's different. For the transition metals, some of these can have more than one charge. And I actually hit on this about a few weeks ago for one day, so you may remember it. So that means when we're naming ionic compounds that have transition metals, we need to add something into the name to tell us which charge it is. For example, let's look at iron. Okay? Iron can have a +2 charge, or it can have a +3 charge. Oops, that's not a 3. Or it can have a +3 charge. So if we're naming a compound that has iron in it, we want to indicate in the name what the charge of the iron is. And so all we do is we use Roman numerals. So we use Roman numerals to indicate charge. And it's real simple. Whatever the charge is, and it's always going to be positive because these are metals, whatever the charge is, we just put that Roman numeral. Does everybody know the Roman numerals?
Yep.
I know some of up until time.
Does anybody not? Should I write them on the board? All right, let me write them anyway, so they'll be in the video just in case my next class. So I'll just put like the first 5 or something. So this will be number and numeral, which of course means number anyway. So 1, 2, 3, 4, 5. So it's just 1 is I, 2 is 2 I's, 3 is 3 I's. 4, there's actually 2 ways you can do it. The more common way for 4 is IV. And this just means since the I is before the V, it's like taking 1 away from 5, because V is 5. And then 6, of course, is going to be I after the V, which means you're adding 1 to 5. So that's it. And then 7 is VII, and 8 is VII, and then change it like that. But up to like 4 is as high as you'll need, because we're not going to see charges any higher than 4 for any of these. So here's what we call these things. This one here, we're going to write iron. And then in parentheses, we're going to put Roman numeral 2 to indicate the +2 charge. And then for the other one, we're going to do the same thing. We're going to put a 3. And the way you say this is simply iron 2 and iron 3. So you write Roman numerals, but you just say it as a number. And if you look at page 254, there's a list of a bunch of them and their common charges. So for iron, like I said, there's +2 and +3. For, I don't know, lead, for example, lead could be +2 or lead could be +4. Those are the possible charges for lead. And so we would write this lead 2 and lead. Lead 4. Okay. And for a lot of them, there's just 2 really common charges. You'll see some of them can have more than 2. So that's it for that part. All you have to do to name the ion is the name of the element and then put a Roman numeral to indicate charge. Now the other thing we're going to do today is I'm going to give you compounds, and you have to name the compound. So you have to know the charge of the metal ion in the compound. Can I erase all this?
Mm-hmm.
Yeah. All right. That's what I said. Can I erase?
I was going to play.
All right. So
Right down.
this part will be called naming ionic compounds with transition metals. And by the way, if you're really observant, you'll notice that not all of these are just transition metals. Lead, for example, is, where's my periodic table? Lead is one of the other metals, right? So even some of these down here in groups 3 and 4 may also act this way, so it's not just the transition metals. And I'm definitely have to put that picture onto the video. All right, so what do we want to do here? Let's do an iron one since we did iron already. So let's suppose we have FeO. So all we have to do is figure out the name of the metal ion and then add the name of the anion at the end of it. So what we're going to do, what we want to know is what's the charge of iron here. Once we figure out the charge of iron, it's easy to name this. So we're going to write this like it's a chemical reaction, but it's going the other way. It's breaking the thing down. So these are breaking down into two separate parts, iron and oxygen. Okay? Now we should know from whatever it was yesterday or the day before what the charge of oxygen is. If you don't know, it's the top of page 254. There's a table there that tells you what is the charge of oxygen. -2. Yeah, it has 6 valence electrons, so it's -2 charge. Okay, so oxygen's -2. This has 0 charge, right? This compound, because it's a compound. So what does this have to be? +2. That's it. Charges have to cancel each other out. So that means this is going to be called iron. This piece is called iron 2, because that's the charge of the iron ion. Iron 2 oxide. Remember, the -1, you change the ending to IE. I'm going to say this about 50 times today. Do not think that this has anything to do with little numbers that go down here. You're going to think it, don't think it. This is the charge of the metal ion. Charge of metal. Okay, we're going to do a different one, and I don't want you to get confused with that. So let's do a little bit harder here. Fe2O3. Okay. All right. So we're going to write the reaction as if it's breaking down into two separate pieces. Iron. And look, there's 2 irons in here. So when these break down, it's going to give us 2 iron ions. And then there's 3 oxygens, so it's going to give us 3 oxide ions. That's not 30, that's 3 with a capital L. Okay. Again, oxide ion, charge is -2, right?
Yep.
I have 3 of them. What's the total charge of those 3 oxygens? -6. What does the charge of all the irons have to be? +6. Because they have to cancel this out. There's 2 of them, so what's each one going to be?
3.
Each one's going to be +3. So I went here, I got the charge of oxygen. That gave me this. 3 times 2 is -6, because there's 3 oxide ions. Then I figure out what this has to be, +6, has to be the opposite. And there's 2 of them, so each one must be +3 to add up to +6. It kind of went this way and then this way. Questions? Okay, let's do another one. Let's do, oh, I gotta name this thing, right? So it's 3, right? The whole point of that was to name that. So it's gonna be iron 3. That 3, iron 3 oxide. It has nothing to do with either one. I mean, it does have something to do with them, but it's not either of those numbers. It's whatever the charge is of this thing. Okay, let's do lead chloride. Let's do that. Okay. So I'm going to get 1 lead ion and 2 chloride ions. What's the charge of a chloride ion? Yeah, 3 minus 1, right? There's 2 of them, so the total charge for both of them is 3 minus 2. Which means the total charge for the leads have to be +2. And there's only one of them, so this one's +2. So it's lead 2, this is called lead 2 chloride. Because this is 2, not that 2. questions? Alright. Can anybody tell me, any guess what's this gonna be? Wait, don't, not yet. Let's do, that's not this. Yeah, no, let's do this.
You supposed to like do work or just like?
Well, we're gonna do work, but does anybody know just by looking at it?
Lead.
Alright, let's do it. I just wanted to see if you guys were kind of able to do this in your head yet. Okay, so here's one lead ion, 2 oxide ions. What's the charge here? -2. So the total is 2 times 2 is -4. 3 plus 4. There's only one of them, so it's going to be plus 4.
So it'd be lead 4.
Lead 4 oxide. Alright. Should I do another one?
Nah. But yeah, if you want to go ahead.
How do you want me to do more examples?
Just do like one more.
One more? Okay. One more.
Man, we overruled her though.
Doesn't matter. This is one of those votes where one vote wins. What's cobalt? Cobalt can be +3. Right? Yeah. Let's do manganese. There we go. MN2O. No, I did too much oxygen. Let's do sulfur.
Yeah.
There we go. Some excitement in my life, right? Okay, so this is going to be some kind of manganese sulfide, but there's going to be some number in the middle. Alright, so we got 2 of these and 3 of these. What is the charge of a sulfide ion? -2. It's right under oxygen, so it's got to be the same, right? So what am I going to put down here? There's 3 sulfide ions, right? Add them together. -2, -4, -6, right? 3 times 2 is 6. Yeah, so this is +6. There's 2 of them, so each one has to be +3. It's going to be manganese 3 sulfide. Parentheses on this one. Make sure you always put parentheses. Alright, we good?
Yeah.
Alright,
That's the
here it comes. On the front page, you're just naming the ion. I give you the charge, so you're just writing iron 3, lead 4, whatever. On the second page, I give you the compounds and you do it with fingers.